When it comes to cutting radiused edges, especially on thick stock, or resawing that figured wood for that special book match, the tool you turn to is a bandsaw. This unique tool can handle almost any application as long as it's been well tuned and adjusted. So let's go over the steps it takes to adjust this 14-inch typical bandsaw. The first thing we can do is talk about the blade. Generally speaking, a high carbon steel blade is about the best for most applications. Now there are upgrades from that blade. You can go to solid carbide blades if you want to give you much more durability. You can also go to a hardened tooth and hardened back blade, which gives you a lot more rigidity. You're going to make a decision based on the type of material you're cutting and the application you're putting with it. The second thing we want to talk about with bandsaw blades is their width. Generally speaking, the narrower the width, the tighter the radius you can cut. The wider bandsaw blades with a little bit more backbone are better for cutting thicker stock or resawing. Now you'll want to match the width of that blade with the radius you're planning on cutting. And the manufacturer will have all the specifications written in the manual. In general, an 1/8 inch blade will cut a 1/4 inch radius, 3/16 inch blade will cut a 5/8 inch radius, a 1/4 inch blade will cut a radius of 1.25 inches, a 3/8 inch blade will cut a radius of 3 inches, and finally a 1/2 inch blade will cut a radius of 5 inches. You may want to copy the chart from your manual and tape it to the inside upper door of your bandsaw for reference. Last thing to talk about is the tooth count or pitch count. You want to choose the highest tooth count that provides the smoothest cut. And that's dependent on the hardness of the stock and also its thickness. But as a rule of thumb, normally 3 to 4 teeth should be on the stock at any one time. So a 3 to 4 TPI or tooth per inch blade for a 3/4 stock is appropriate. And you'll want a higher pitch count for dense woods. Pictured are a 3 TPI, a 4 TPI, and a 6 TPI. And the last blade is actually what's called a variable pitch blade. This has 2 to 3 TPI, and what it has is rather large gullets. And you'll see they're spaced with 3 teeth, then 2 teeth, then 3 teeth. They're used to resaw stock, and that variable pitch pattern eliminates a lot of the harmonic vibration that happens when you're trying to cut thicker stock. Those deeper gullets also help remove a lot of that extra material when you're doing resaw. So one of the first adjustments or one of the first checks you can make to your bandsaw is to make sure that blade is tracking in the center of the wheel. And you'll find that wheel set up just behind the door. And there's both an upper and a lower door. You can see in this case this blade is tracking just a little bit ahead of that wheel. Tracking knob in the back, when I spin this by hand, allow me to very carefully move that blade until it now tracks right in the middle of that wheel. When you do that adjustment, of course, you want to make sure that all your guide bearings and thrust bearings are pulled well away from the blade. You'll be doing that anyway when you set up a new blade in your saw. Once I've done that and I'm pretty sure that my blade is in the center, I want to do one more quick test. I'm going to turn the saw on for just a second and let it spin. Sometimes when the saw kind of picks up that blade, it may change that pitch just a little bit. I want to do that first, then shut it down, then check my centering again. So we'll do that real quickly. Now that I see what the saw started, the blade still stayed in the center where I want it. Now it's time to lock the tilt on the back of the blade and we're ready to go. Now, as long as we've got the guides pushed back out of the way, it's time to make sure the table is square to the blade. So I'll take a small little machinist square, slide it up against the side of the blade, and see how close we come into alignment. And that actually looks very good. If it were off a little bit, we have the tilt stop that we can adjust to make sure that that table sits perfectly at 90 degrees. Secondly, we want to take that square and move it to the back of the blade, again making sure that the back of the blade is lined up square to the table. In this case, we don't have any tilt adjustment, so you may wind up having to shim the trunnion bolts underneath to align it. But once you do, it'll be set forever. So now it's time to set the blade guides and the thrust bearings. And that's fairly easy. We've already centered the blade, we've already checked it for square, and now it's just time to finish up this operation. So the first thing is using an Allen wrench in this case. We're going to loosen up the bearing guides on one side and the other side. To make this a little bit easier to see, And also for the correct spacing, I'm just going to take a little piece of painter's tape and put it on the blade. I'll slide the painter's tape up into position and just gently ease over each one of these little bearing guides until they just lightly kiss that tape. Tighten it on one side. Now tighten it on the other. So it should very easily just pass through that tape, so just touch it. And the last adjustment up on the top is a thrust bearing. That's the bearing behind that blade. Want to push it up until it just touches and then back it off about a 32nd of an inch. So we're going to come forward until we just touch that blade right there, and then come back just a hair before we tighten it. That way, when pressure is placed on the blade from the front, thrust bearing will keep it from going too far back and keep the tooth and the gullets in front of those edge guides. The same process happens on the lower blade guides and also thrust bearings. Once that's been adjusted, your saw is pretty much ready to go. When you run a bandsaw blade, it has to run under some kind of tension. That will keep it running true and keep it from running off the wheel. Depending upon your saw, you'll have a little gauge someplace on the saw that equates both the width of the blade with the amount of tension that's supposed to be on it. And those can be good and bad. It just kind of gives you a general idea. There is a way to get a much better idea, or a feel for it, if you will, by using a small little square. Normally what I'll do is I'll adjust my tension depending upon what the bandsaw says it should be, but then to double check it, set a small square back here about 1/4 of an inch away from the blade with the guide all the way up, and see if I can press that blade and have it just touch that square. And as long as it just touches that square or gets very close, I know that the blade is tensioned correctly for me and for the project that I'm planning on doing. It's an easy way to do it. You can use the guide if you want to. This works every time. Another thing that will help your blade run true regardless of the thickness of the material you're planning on cutting is to take that stock, whatever the thickness is, and set your blade guides down to within about 1/4 of an inch of the surface. The closer you can keep those blade guides, the tighter that blade will be passing that cut, and the truer and cleaner that cut will be. Well, one of the things you'll find as you're trying to cut a piece of wood in the bandsaw is a tendency of that cut to kind of go offline, and it's called blade drift. Now, to be honest, a perfectly tuned saw shouldn't, but they do. So one of the things I want to show you is a way to offset that, a way to judge how it's going to work and to set your fence so that you don't have to worry about trying to follow that board through. I'm going to run a board through, follow that cut line, and you're going to watch that it's not cutting exactly straight. Once I'm about 2/3 of the way through, I'll stop the saw. We'll put a pencil line on the fence side of that board, and then you can align your fence to match that line. So now, in effect, you've matched the drift line of that blade. So here's how it works. Okay, well, you can see the saw cut line. It's taken this board and shifted it very slightly to the back edge. I'm going to take a pencil, mark this edge of that line, so now I have a reference point, and I can put my fence on there, and I can adjust my fence to match that line. That will take care of that drift point, and you'll be cutting then to follow the fence and not worry about that blade drifting back and forth in your cut line. Now you can see I've drawn my line on here. If you have a fence that came with your machine, or maybe an aftermarket fence, your fence now can be adjusted, loosening a couple of bolts and moving that fence back and forth to align with that line. Many 14-inch bandsaws don't come with a fence. There's a very simplistic solution to do the same thing. Just taking a 2x4 here and kind of rounded the edges on it a little bit, give us a little bit of sawdust relief. And what I'm going to do is just measure back from this line to match the line I'm planning on cutting on a piece of wood. So I've already got my index line in here, measuring back on either side to make sure it's parallel. I'll clamp my makeshift fence in effect. And I've drawn a line on this board, and we'll show you how that new angled fence will follow the line. So you can see that makes the process pretty foolproof, relatively simplistic way to fix what normally is considered to be a relatively complex problem. Nothing to it. Well, I want to show you a second type of fence. This is called a point fence, usually used to cut nice thin pieces of consistent veneer off tall pieces of material or follow somewhat convoluted lines in a layout that you've got on a piece of wood. The heart of this jig is this small wooden block, and all I've done is round the nose on it, and I drew a pencil line down the center of that nose, or the apex of that nose. And the way for this jig to work is to make sure that center line sits about a 1/16 of an inch on my side of the teeth, on the high side of those teeth, and then spaced for the thickness of the wood that you want to cut. I'm going to pass a piece of wood through here. You'll see we get a really nice, well-supported, thin piece of veneer as it comes out of the back side of that. Here's how this works. Now we've cut a nice thin piece of veneer here. We've supported this work really well. It's a great additional fence to build for your saw. A lot of saws don't come with them. Sometimes they're available as aftermarket, but it's an easy jig to build, and I'm sure you're going to wind up using it.